All right, let's go over question now B1. A local arts festival has 150 vendors and 75 volunteers. Each volunteer receives a T-shirt and earns $2 for every hour spent volunteering towards a gift card for the festival. Model the value of gift card that a volunteer can earn. Okay. All right. Here's a great thing about word problems. There's a bunch of stuff you don't need. So let's cross this off. Who cares that it's a art festival and vendors and volunteers? Don't need that information. Okay. But you do know that. Okay. Who cares about T-shirt? But I do want to know what this next part is. Earns $2 for every hour spent. $2 for every hour spent. Okay. And we have a table of values here. So each hour means 1 hour. Okay, so then I see hours down here. So let's just make, what happens if you volunteer 1 hour? Well, it says, use a different color, we get $2 for each hour spent. $2. So this represents money. Okay. From the last example, does independent x-axis always represent? Yes, it does. So, and the y coordinates always represent money. So if you spend 2 hours there, you're getting $2 for every hour. So that means $2 the first hour, $2 for the second hour. That means you get a total of $4, right? And then 3, you get $2 for each hour. So 3 times 2 is 6. 4 times 2 is 8, and then 10. Okay. So model each statement using a table. So this is a table because you have a x and y coordinates. Okay. The second thing we need to do is now put this on the graph. Let's put this on the graph here. Okay. So we said x is hours. So here's our x, and this one's nice. There's my hours, but pay attention now. It's not done for us. We have to do it. So there's my 1, 2, 3, 4, 5. Okay, so I decided to just use 1, 2, 3, 4, 5. Okay, and then the y's represents money. We talked about that, right? So 1, let's just graph these order pairs. Right 1, that's 1, up 2. And in blue, I'll put the coordinate. Okay, and then the next, we just did this one, right? Let's do the next one. 2, 4. Okay, right 2, and then up 4. Just did it in pink. Right 2, and then up 4. And that gives you the order pair, blue, 2, 4. And then you can just keep going. Right 3, up 6. Right 4, 4 hours voluntary gives you an output of $8 and 5, 10. Oops, I did it again. Where are we? Here we go. Right here. Sorry. And then 5, 10. Okay, so there's my table of values. I don't know. If I was a volunteer, I don't really want to do change, so I would probably make this discrete, it's called, which means you would not kind of connect the dots. Okay, if you want to show a linear equation, you can. Wish I had a ruler to be able to draw straight on this. I don't know how to do it yet. But that's to help you visualize that it's a linear. So we got a table over here, we got the graph, and now it wants an equation. So let's write an equation, okay? So linears are in the form of y equals mx plus b. Let's see if I can show it to you on 2 ways, okay? The b value is the y-intercept. Where does the graph hit the y-axis? It is right here. It is what number? It is on the y-axis here, 0. 4, 2, 0. Okay, where is this on the table of values? You actually have to go backwards. and I like to write it up here, it would have been 0 and 0. Okay? So your y coordinate would have been 0. So what stays the same in here as you're writing an equation is your y, the equal sign, and x. So how do I get an m value? The m value is going to be my first common difference. Let's try to see if we can find this here, right? Plus 1's over here. What's over here? This one's going to be 2. So this is my change in the y's over the change in x's. So that's going to be 2 over 1. And 2 divided by 1 is 2. So my equation is y equals 2x. You don't have to write the 0 there, okay? How do you get 2 from the graph? Remember, it's rise of positive 2 and run, which is positive 1, okay? Rise 2, run 1. Rise 2 over 1. You can do this all day long till you get bored. Up 2, right 1, okay? And that's how you find this number 2 here. So my equation is y equals 2x.